Dear students, so last class discussed about the basic concept about disjoint set operation, that is make set, create a new set, find operation, whether the element is in that set available or not, and third one is union operation. So when you are performing the union of two different set, if the numbers are repeated, then we have to do, that is when we are merging that time, if the numbers are more than one time is repeated, we have to write only one time. Okay, so now let's see about the another continuation of disjoint set operation, that is how to represent the set. Yes, as I earlier said that disjoint set operation is a data structure. So why we are going for a data structure? Because the efficiency of an algorithm sometimes what it depends on the using of efficient data structure. So we have different data structure, you already know that. So a good choice of data structure can reduce what? Execution time of an algorithm. Okay. For example, for the same problem, I will write one algorithm. You may write another one algorithm. Some others may be write another one algorithm. Among these three, which algorithm execution time is minimum? That algorithm is best. So union find is a data structure that falls in that category only. Okay. Suppose if we have a set of n elements, okay, these elements are partitioned into some another subset, S1, S2 up to Sn. If you have to keep track of connectivity of each element in a particular subset, what will you do? Otherwise, the connectivity of subset with each other, you have to do this operation efficiently using union find data structure. Okay. So I will say another one example. Suppose there are 5 peoples. Name is A, B, C, D, E. A is a friend of B, and B is a friend of C, and D is a friend of E. So we can see A, B, and C are connected to each other. Okay, that is one set. D and E are connected to each other. That is another one set. Okay, so we can use the union find data structure whether to check one friend is connected to another in a direct or indirect way or not. That is, we are using for union find data structure. And also we can determine whether two different disconnected subset. Okay, so here two different subset are what? ABC is one set, D and E is another one set. So we can perform the union operation A comma B with these two set and find operation, that is path connecting of two elements A and B. Okay. So in this example, how to represent the disjoint set using arrays? Okay. So we already know that array can be used to store the parent of each element. Okay, here we have for the previous example, n equal to 11 elements and 4 set, S1, S2, S3 and S4. Okay, so the first set contains the elements 1, 7, 10, 11. So the root is 1. So what is that? As per the rules of disjoint set, all the remaining elements are pointing towards the parent node. Here 2, 3, 5, 6. Suppose 3 is the root node and 2 is the subnode and 5 and 6 are another subnode. So these two are all points to node 2 and 2 is pointing to node 3. And yes, 3, 4 and 8. Suppose 8 is the parent node, then 4 is the child node. That child node points to parent node. And the set 4 contains only single element 9. So the ith element of the array, it represents the tree node. It contains the element I and it gives the parent of that element. So when you are representing the array format, the root node has a parent -1. So here what are the root node? 1, 3, 8, 9. So this has the parent is mentioned as -1. So these are the elements, these are the parent node. So 1, -1. Here 3 is the root node 3, -1. Here 8 is the root node 8, -1. 9 is the root node 9, -1. Okay. So the array is the parent of n elements can be taken for all elements in the disjoint forest set. So here each element of the node is taken as the name of the set. So remaining, how can you fill that? Suppose the elements are written in ascending order 2, 3, 4, 5, 6. So that the roots are filled with the -1 and 2. So 2 is where it is points to the node value 3. So 2 is pointing to the node value 3. And 3 is the root node, so already -1. Next one 4. Where it is 4 here, it points towards the root node 8. So has that parent node 8. 5. 5 is pointing to 2. Okay. So 5 is pointing to 2. 6 is also pointing to 2. So 6 is also 2. Next 7. 7 is the child node, it pointing to the parent node of 1. So it is 1. And 8 is root node, already we measured as parent is -1. And 9 is also parent node -1. Next 10. So where is 10? Here. 10 is pointing to the node 1. So it is 1. And next 11. 11 is also pointing to the node 1. So it is 1. So it is the array set representation of that disjoint set. Okay. So as I said initially, how that algorithm it works. So union of two elements, I and j. What is that? We have to merge these two elements. That is, I is 5, j is 7. Suppose I is 5, j is 7. So you have to merge these two algorithms. That is, p of I equal to j. Okay, that is 5, 7. And you have to find the operation of that algorithm, find operation. Suppose you want to find any one of the elements in that set. So that time you have to set check the condition, that is I, p of I greater than equal to 0. That is, it contains more above 0, not a -1. So above p of I. So where it is available p of I, the time it is assigned as I, and we have to return the value of I. So these are the simple union and find operation. Now, let's see how the union find these two disjoint set operation is working. So we have to determine whether these two elements in the same set by comparing the result of two find operations. That means we have two different elements. Okay, two set S1 and S2, two different set. If the two elements are in the same set, S1 contains S1 elements also contains 5, S2 also 5, then we have the same representation. So it belongs to different set. And the union is called on two elements. We have to merge two subset to which the two elements belong. And next one, how to implement the disjoint set. So as I said, no, when we are performing the disjoint set operation, we have to make the set union operation, find operation, because the data structure is an efficient way. We have to find the elements. Time complexity will be reduced. Okay, for that we are using the disjoint set, union and find operation. So it is also another name is called disjoint. For it set is a data structure where each set is represented by a tree data. Okay, tree data. Here each node holds a reference to its parent, and the representative of each set is the root of that set tree. That is only as I explained in that previous slide. So here each node is that parent node, and remaining all the nodes are pointing towards the parent node. That is here each node holds a reference to its parent, and the representative of each set is the root of the set tree. So here the find parent allows the parent nodes until it reaches the root node. Okay, from bottom to top of approach. And union means we have to combine two trees into one tree by attaching the one tree's root into the root of other tree. So how this is happened? Okay, so here as I give one example, that is 5 set S1, S2, S3, S4 and S5. These are all 5 different set, and the values of S1 is 1, S2 is 2, S3 is 3, S4 is 4, S5 is 5. Okay, so these are all separately represented by a tree. So these are all separately represented in the tree. So here each set initially contains only one element. Yes, S1 contains only one element, S2 is 2, S3 is 3, S4 is 4, S5 is 5. So the parent pointer points to itself or null. The parent node is pointing to the same node itself. Initial condition. So when we are finding the operation on the element I, it returns the any one of the set Si, that is 1 less than or equal to I less than or equal to 5. That is the finding of elements is it is any one of that set S1 to S5. Let's see if you perform the union of S3 and S4. Okay, perform the union operation, set S3 and S4. So it will merge into one disjoint set, that is S3. So what is in S3? S1 is 1, S2 is 2, S3 is merging of S3 and S4, because we are perform the union operation 3, 4, and S5 is 5. Suppose we are finding the value of 4, it will be returned from the set S3. So find of 4 is equal to 3. So S3 and S4 is merged. At that time the pointer is pointing, that is S4 is pointing to S3. So there is no pointer for S4. It is pointing to the node S3. Okay. Suppose we are doing S1 and S2, merging of these two subset union operation, then how can you represent this one? That is merging of S1 and S2 in the S1 itself. So S1 contains 1, 2. Okay, because S1 is 1, S2 is 2. So merging of these two is 1, 2. So that time the S2 is points to S1 and S1 contains the only pointer node. So suppose we are finding the elements 2, so it is where it is available. It is available in the set S1, so 1 is written. Okay. Now we are finding the union operation of S3 and S1. S3 and S1 means what? S3 is 3, 4. S1 is 1, 2. So when you are performing this one, the result is S3. So that S3 contains the only pointer node. So 1, 2, 3, 4. And we have the only pointer node. This is separately S3. This is S1. When S1 points to S3. So this is the diagram. Here only one pointer, that is S3. And S5 is separate one. Now we are performing again union operation of S3 and S5. What happened that the time that S3 is pointing to the node S5. So we have the only one pointer and S3 equal to 1, 2, 3, 4, 5. Okay. So this is the another one pseudocode for implementing that find operation. That is, first initially we have to make the set that X contains the number of elements. Here the X is the first element is the parent node, that is X dot parent. If the X dot parent is equal to our finding element, suppose X is that, we are enter the element, some elements in the set value. So that is equal assignment operator. Whether this is equal to this value, then it returns the value, else it is find the X of parent value, another set. Okay. So suppose we are finding the union operation of two set, that is X and Y, then we have to find the root of X equal to find of X and Y root equal to find of Y. And we have to find whether the root node as the parent node. So that's all for disjoint set. So particularly we are explained about how to make the set, how to create the set, how to find the union operation, how to find the elements. Okay. How to represent the disjoint set by using tree representation and set representation using array. How the values are assigned in array. Okay, with the examples we are explained. So thank you for watching.